So hello everyone and welcome to this webcast in Cisco Super Committee. Today we will be presenting the live expert series webcast, and our topic will be what's new on Cisco Catalyst 6500 series switches. My name is Satish Chandran and I'll be moderating today's event. So we have two experts joining me today, Richard Michael and Somu Jayaraman. Richard is an engineer with technical services at the Cisco TAC India. Richard's areas of expertise include LAN switching and data center products such as Cisco Catalyst 6500, 4500, 3750, 2960, and Cisco Nexus 7000, 5000, and 2000 series switches. The other expert, Somu Jayaraman, is a customer support engineer with Cisco TAC India. His areas of expertise include LAN, routing and switching, and data center technologies. Somu has been involved in various escalation requests from India, Singapore, and Australia, and is currently a technical lead for the LAN switching team. So welcome Richard and Somu.
Thank you, Satish. My pleasure.
Thank you, Satish. Okay, great. So in the expert panelists, we have Subhaya and Varun. They will help in answering some of your technical questions while Richard and Somu are presenting. Now I'd like to briefly outline the format for today's expert series webcast. Our expert will start with a presentation on what's new on Cisco Catalyst 6500 series switches for the first hour of the program, and then we will dive into the live question submissions from the audience for the remainder of the event. During our live presentation, you may submit your technical question to be answered by our presenters and the expert panelists using the Q&A panel, which is on the right-hand side of this console. The team of technical experts is well versed in Cisco Catalyst 6500 series switches. So please begin posting your questions now to give them a best chance of answering. And we'll be asking some of the polling questions during this webcast, and we highly encourage you to participate by answering them. And right now you can see the link on the slide. So this is the PDF copy of today's presentation, which you can download from the link. The link will be shortly posted in the chat window as well. Okay, so let's get started with first polling question. The question is, what is your level of experience on Cisco Catalyst 6500 platform? Option A, I have plans to implement this soon in my network. Option B, I have set up this in the lab and testing. Option C, I'm running it in the production. And option D, I'm an expert with 6500 series of switches. The poll is open on the right hand side. So let's take a few seconds and you can record your responses. This will give Richard and Somu the best chance to tailor their presentation. Thank you. Let's take a few seconds. So while the poll is on, make sure you submit your questions via the Q&A panel. Okay, so there you go. So now I'd like to hand over the mic to our experts for the rest of the presentation. Over to you, Somu and Richard.
Thank you, Satish. Hello, everyone. Thanks for joining the session. Today we are going to talk about what's new on Catalyst 6500 series switches. Here is the agenda for today's presentation. We are going to talk about in detail the comparison between the Supervisor Engine 720 and the Supervisor Engine 2T in terms of hardware and in terms of capacity, and also in terms of inbuilt troubleshooting tools what we have in SUP 2T. And we are also going to look at the next generation switches 6800IA and its detailed overview and architecture. And following that, we'll be open up for Q&A. So what's 720 in SUP 720? Basically, 720 is a number which we get from SUP 720. Basically, what it means is the SUP 720 is capable of delivering 720 Gbps of bandwidth as a system. So how it does, here is the explanation for that. There are two fabric channels per slot. Slots 1 to 8 is a single fabric channel, and slots 9 to 13 is a dual fabric channel. So there are total number of channels of around 18 in the complete 6513 chassis. And there is a 20 Gbps full duplex per channel. So if we calculate 18 channels into 20 Gbps into full duplex, which is receive and transmit, we will get around 720 Gbps of full backplane capacity. So here is the SUP 720 architecture. So we have two components in the Supervisor Engine 720. One is the MSSC complex and other is the PSC complex. MSSC complex is a integral part of the control plane, which means it has RP CPU and SP CPU integrated to it. So when I say RP CPU, it means the route processor CPU, and SP CPU, it's a switch process CPU. So RP processor is responsible for layer 3 control plane such as OSPF allows, HSRP allows, BGP keep alive, and SNMP. And SP CPU is for the layer 2 control plane, which will be responsible for processing the BPDUs, the LACP PDUs, and all the other layer 2 functionalities. We also have a PFC complex, which is mainly responsible for the hardware forwarding. We have a layer 3 and layer 4 ASIC and layer 2 ASIC as well, which is capable of doing the layer 2 and layer 3 functions in the hardware level. As you all aware, not all the packets will be switched in the CPU. Only the first packets hit the CPU, and the CPU in turn programs the hardware, which is the PFC, and the subsequent packets will be forwarded through the hardware. So the layer 3 engine and the layer 2 engine is responsible for that. So how it does, we have multiple Tcams in the hardware level, the NetFlow Tcam, the QoS Tcam, the adjacency Tcam, FIP Tcam, and ACL Tcam. So if you are using a NetFlow, all the NetFlow entries will be stored in a piece of memory, which is NetFlow Tcam. So whenever there is a lookup needs to be done, the layer 3 engine will look into the Tcam and get the entry, and the result lookup is built based on that. Similarly, we have QoS Tcam. The QoS Tcam, we will have the policy map configured, and whatever ACLs we are mentioning in the class maps, that will be in the QoS Tcam. So the ACLs that you are going to call in the class map will be there in the QoS Tcam. The adjacency Tcam and the FIP Tcam is an integral component which will work for the routed packets. The FIP Tcam will have all the routing entries, and there will be adjacency pointer which will be there in the adjacency Tcam. And the ACL Tcam, as you all aware, all the ACLs will be programmed in the ACL Tcam. So the one thing we need to note is the normal ACLs will be stored in the ACL Tcam, and the ACLs that we apply in the class map in a policy map will be there in the QoS Tcam. It will be programmed in the QoS Tcam. And we also have a fabric interface and replication engine, which is responsible for replicating the packets, such as multicast, span, where we need to replicate the packets. So the replication engine is a main component for that. And we also have a switch fabric, which is responsible for sending the packets to the other line card, which is fabric enabled. Just note down the link between the fabric interface and the switch fabric. It is 20G. We will talk about this in detail in the upcoming slide, how different the SOUP2T capacity is. Okay, what's 2T in SOUP2T? As you all guessed, it's a 2 terabit speed, around 2080 Gbps bandwidth it can provide if you use a SOUP2T. So it is way more faster than the SOUP720, and let's talk about that in detail. There are 2 fabric channels per slot. Slots 1 to 13 is a dual fabric channel, and as you note, in SOUP720, slots 1 to 8 will have only single fabric channel, whereas when we use SOUP2T, the slots 1 to 13 will have dual fabric channel, and hence the total number of channels is 26. So 26 channels into 40 Gbps into full duplex RX and TX will give us 2080 Gbps speed. And as you all know, we will be seeing in the upcoming slide, the RP CPU and the SP CPU is integrated into a single CPU in the 2T, which makes the 2T to boot up faster compared to the SOUP720. Here is the SOUP2T architecture. Similar to SOUP720, we have 2 complex, MSFC complex and the PFC complex. As you see, the RP CPU and the SP CPU is integrated to a single CPU. And also, the link between the fabric interface and the switch fabric is 40G, which enables us to get 2048 Gbps out of it. And also, the L3 and L4 engine, which is same as compared to SOUP720, but the ASIC we are used here is very faster capable. Whenever the packet needs to be switched, it will be switched at a very high speed. And as you see here, there are NetFlow Tcam, ACL Tcam, adjacency Tcam, flip Tcam. So all the Tcams remain same. The one common or interesting feature which we have is LIF. So we'll be talking about the LIF, the logical interface, in the upcoming slides. Here is a overview of the SOUP2T. So the L3 and L4 engines, how it will perform, or whenever a packet is received on the L3, L4 engine, it will look into the individual Tcams based on whatever features configured on the interface, and the results will be populated and the results will be sent across the RBus. And once the RBus gets the result, the packet which was entering in the port ASIC, as you know, whenever the packet hits the port ASIC or the port, only the header will go to the lookup engine for forwarding or for the lookup. Once we get the result, then only the entire packet will be transmitted across the fabric and it will reach the egress line card or the egress port. So the header, once it goes to the lookup engine, all these features will be checked, then only the result will get populated. So here are the features of individual Tcam. So FIB Tcam, which will have the CEF IPv4 and IPv6 prefixes as well as MPLS entries, and the adjacency table will have the layer 2 rewrite information and the pointers. And the ACL classification table or the ACL Tcam will have the ACL entries. And if you look into the NetFlow, right, we will see a difference, because in SOUP 720 we don't have all these tables. We just had a NetFlow Tcam. So you're right. So basically, the NetFlow, how it works in SOUP 720 and SOUP2T is entirely different. We have flexible NetFlow in SOUP2T. So we will be talking about that in detail in the upcoming slides. So here is a detailed comparison in terms of the line card as well as the capacity difference between SOUP 720 and SOUP2T. So SOUP 720 supports the classic line cards, whereas SOUP2T doesn't support classic line cards. Switch fabric, yes, we have 8 Gbps and 20 Gbps channels, whereas in SOUP2T, 20 Gbps and 40 Gbps channels. Line card connection, single or dual. Similar, SOUP2T also has single or dual channel. Supports classic line card, yes. Supported on SOUP2T, no. CEF 256 line card, yes, and it is not supported in 2T. CEF 720, yes, it's supported in both 720 and 2T. Supports line card with DFC, yes, only DFC3 is supported by 720, whereas it's not supported on SOUP2T. We need to use DFC4. Because the PFC which we are using in 720 is DFC3C, the PFC3C, whereas in SOUP2T it's PFC4. So the complete version change is there because of the ASIC which is there in both the PFC part. Support for VSS, yes, but again we need to use DFC4 line card. Support legacy service modules, fabric mode, but SOUP2T supports in bus mode. Supports 16 slot chassis, yes, we have a single channel from slot 1 to 8, dual channel from slot 9 to 13, whereas in SOUP2T all the channels from 1 to 13 is dual channel. New Supervisor Engine 2T elements. So we have a switch fabric which can support 80 gig per slot. There is a new fabric which we have introduced on the SOUP2T. And the complex, the MSFC complex which is present on the SOUP2T is MSFC 5, whereas in SOUP 720 it was MSFC 4. The main feature we have in MSFC 5 is the dual core CPU. The RP and SP CPU is integrated and a single iOS image. As you are aware, in SOUP 720, even though the image is 1, while booting up, the SP boots up first and the RP boots up afterwards. So basically there is an image extraction happening between RP and SP. Whereas it's not the case for SOUP2T, it's a single image, and that's why the boot up process is far faster compared to SOUP 720. And we have a connectivity management processor, CMP. I'll be talking about this in detail in the upcoming slides. And we also have USB based console support, and actually it works in SOUP2T. And new PFC4 which has an improved level of performance and scalability along with the new enhanced hardware features, such as the NetFlow Tcam, which we have multiple tables which will help us in faster lookup and faster processing of the packet. What is CMP? The CMP is called as Connectivity Management Processor, which can support new capabilities that will aid the network administrators in managing the system. So basically, in SOUP 720, we do have a console, but consider the CPU is high. The response on the console will be very slow and sometimes the system might hang. So we have implemented a new feature called CMP in the SOUP 2T, which will have a dedicated CPU. So irrespective of the CPU hogs, we will be able to get access to the device. So at any point of time, we will have access to the device, irrespective of the CPU hog. We don't need to have a telnet server because we will have a dedicated console. There is a separate CPU for that, and remote reset of the switch. We can do a soft reset or hard reset, remote image recovery via TFTP boot, and we can also use USB port for booting up the image. And we can also access the console through the USB port. And when we do a console, it will directly give access to the route processor. And we also have a message logging monitoring system as well. Okay, here is the polling question 2. What are the common issues that you face during the migration from SOUP 720 to SOUP 2T? Option A, configuration issues. Option B, hardware issues. Option C, absolutely no problem because of good migration documents what we have in CCO. One never know what happens. So let's give some time. Okay, great. I see the poll results, and the top one is the configuration issues. Okay. And hardware issues 29%, and absolutely no problem. And okay, great. So I see the majority challenge that we have is the configuration issues when we move from SOUP 720 to SOUP 2T. And yes, because of the syntax change in terms of flexible NetFlow or QoS, definitely. But we have enough CCO documents for that, and we will also share some best practices and guidelines, to overcome that in the upcoming slides. Okay, so here is inbuilt troubleshooting tools what we have in SOUP 2T. Okay, the first topic in that would be the control plane protection. So as you know, it is very necessary or important to have the CPU not spiked up. The CPU utilization should be well under control so that the OSPF packets or the HSRP packets which needs CPU processing can be done easily. If the CPU is high, then all the instability will take place. The HSRP hellos might get dropped, the OSPF hellos will get dropped, things like that. So to protect the control plane or to protect the CPU from going high, we have an inbuilt tool called as control plane protection. We will call it as a COP. So what we are going to do here is we are going to apply a policy map on the control plane for certain features. So as you know, packets like TTL1 and similar to those will hit the CPU. So we can apply a policy map on the control plane level so that only certain number of packets can go to the CPU and the rest will be dropped. So this is how we are going to do. If we apply a service policy with around 3000 packets as a mark, so from each supervisor engine to the DSC line cards, only 1000 packets per line card will be allowed. So in total, to the CPU, only 3000 packets reaches the CPU actually. And also, as you know, the COP will take place usually on the supervisor engine, but if you have a DSC, the DSC will also have an inbuilt mechanism or inbuilt ASIC where the COP can be implemented, but the other line card doesn't have. So when we apply a COP, the supervisor engine DFCs will play a major role, and it will make sure only the necessary packets will go to the CPU so that the CPU, we will have enough resources on the CPU. And in SOUP 720, we will use a command called show MLS rate limit. Here, we have to use the command show platform rate limit. And just to let you know, all the commands or most of the commands have been replaced by show platform. So if you have a show MLS, if you have used show MLS in SOUP 720, here we have to use show platform. So show platform rate limit will show us what are all possible options that we have in terms of protecting the CPU. So Ceph receive is a rate limit we have, and IP errors, ICMP no route, ICMP redirect, and TTL failure. The most common problem we will see is the CPU will get hogged because of lot of ICMP redirect happening. So by using this rate limiter, we will be able to protect the CPU. And this is how we will configure platform rate limit, and we have to go into the sub configuration modes. If you want to block ICMP redirect, you have to go into the unicast mode, and you will see the option there. In SOUP 720, we would have used MLS rate limit command. And the next troubleshooting tool, which I'm going to talk about, is the ELAM. And I would advise to use this ELAM tool with the presence of TAC engineer. So why I'm saying this? Because the ELAM output we will get is in terms of very internal indexes, the LTL indexes. So the TAC has a tool to decode those and give us or interpret the outputs. So this is how we will use the ELAM. We have to first enable the service internal, after which we will be able to execute the command show platform capture and ELAM and ASIC Eureka and which slot it is. So the DFC will be having the Eureka and the Lamira, which is the layer 2 and layer 3 forwarding engines in the PFC. So as of now, slot 5, which is the Supervisor Engine slot, and we have to set a trigger what packet I would need to capture or want to capture. Show platform capture ELAM trigger, master, Eureka 5, slot 5, instance 0, and the dbus, dbi, ingress if VLAN is equal to 1006, which is the internal VLAN. If we have created a layer 3 interface, we would get an internal VLAN like this. And how to check whether we have configured it correctly? Show platform capture ELAM status should show that. So the trigger is set, but it has not started. So to start it, show platform capture ELAM start, and to check whether the packet is captured in the ELAM or not, we have to execute show platform capture ELAM status. And just to let you know, we can capture only one packet in the ELAM at a time. And here are some high-level view on what are all the steps involved in terms of COP troubleshooting. Show platform rate limit will show us what all rate limit is configured and what all rate limit is not configured. And show policy map control plane will show is the packets hitting the control plane, how much it is getting forwarded, how much it is getting dropped. And also to let you know, the control plane policing on SOUP 2T is enabled by default, whereas it's not enabled by default in SOUP 720. So if you see some packets are getting dropped or silent packet drops, definitely I would suggest checking the control plane policing and see if any of the counters are incrementing. And there is another show command, the show platform data path ingress. That is similar to an ELAM tool where we can capture one packet at a time. And again, I would suggest to use this command with the presence of TAC, as the outputs from the data path command is very internal. And show platform hardware statistics exception, this is similar to show MLS Ceph exception output. If it is true, then everything will not work because there is an exception in the Ceph, and definitely we would need a reload or something wrong with the hardware. If it is false, then everything is fine. And there is another tool, NetDR, it's there in the 720 as well. We can, what are all packets hitting the CPU? If we do a debug NetDR capture, we will see it. And this is the output from show platform data path ingress. And as you see, most of the values are internal or it's in the hexadecimal. So we have some special tools to decode that. And just to see whether COP is enabled or not, you can see COP is applied for this particular packet, or this particular packet will get affected by the COP. So there are some interesting fields here. You can have a look into it. And a snip of show platform hardware statistics exception. So the next topic would be LDB resources. I'm handing over the mic to Richard, who will be covering LDB resources as well as the 6800 architecture in detail. Thank you, Somo. So we've got a logical interface. Logical interface simply means that we have a port and VLAN pair, and each LIF would be associated with an L2 counterpart bridge domain, and that's why we increased the limitation on SOUP2T to a 16K VLAN limitation rather than compared to 4K on a legacy platform like a SOUP 720. So each LIF database entry will contain logical interface information, the bridge domain information, bridge domain which contains the port and VLAN pair, and then the control bits. So the reason why I'm discussing about the LIF and the LDB is we are going to use these terms in the upcoming slides for the forwarding of the SOUP2T, and we are going to need these informations in order to proceed further. So there's also a mini protocol analyzer in the SOUP 720 where we can run an inbuilt capture and find out what packets are exactly getting punted to the CPU. It's like an RP CPU span. More details can be found in the link. We do have a flexible NetFlow concept in SOUP2T that's called NetFlow version 9. And what we are going to do is the simple steps that we are going to follow right now is we are going to have a flow record. We are going to have a flow exporter. And what we are going to do is we are going to match certain key fields and collect the key fields and then export the data to a collector. So how are we going to use this NetFlow in order to troubleshoot our problem? So let's say a scenario where you're faced in high CPU in your switch, but you don't have the option to run any debugs. So you can go ahead and run or create a flow record and do it. Let me show you how we can do it. So that's the end where you define a monitor and apply that to the interface. I'm going to go in detail right now. So right now my process shows that I have high CPU process, that's about 65%. And what I'm going to do is I'm going to collect all the data that's going to hit by IP to the SOUP engine. So I'm going to define a record, match the IPv4, and collect the interface input. And what I'm going to do is I'm going to call the record under the monitor and then define it under the control plane. And then what we are going to see is with this command, we know the top talkers between a source IP and the destination IP. So from this, we can sort out very easily that, who is the high number of talkers, and we can, trace the IP and find out who's causing the high CPU. So we can able to see that the counters are getting incremented rapidly. We can also go ahead and clear the statistics counter using the command. So we can also define an access list, match it, and call it in a policy map, and we can also police it. This is after identifying the source IP and the destination IP. The specific data we got it from the NetFlow. So there are a lot of other usages for the flexible NetFlow. So we define exactly what fields we need, but we don't have that feature in the NetFlow v5 in the SOUP 720, but we do have that in SOUP2T. So here's a schema that will help us in understanding how to troubleshoot key NetFlow issues. So whenever you're migrating the setup from SOUP 720 to SOUP2T, you need to just follow the flow chart and make it simple. You will see all the records getting exported. So many of the customers will say that they are not getting fields getting exported. That's a common issue. So I'm going to cover this in detail right now. So you need to first identify what are the key fields and non-key fields, like interface counters, etc. And then you have to define a flow record. So in the flow record, you need to match whatever information you need, and whatever information you are matching, you need to collect that same information. So if you're not going to match, and if you're not going to mention collect, you're not going to see any data in the collector. So after defining the flow record, there's going to be a flow exporter. Under the flow exporter, you're going to mention the destination and what source. Sometimes customer will use an VRF. They need to be very careful in that. So they need to mention correct VRF if they are using a VRF configuration. So after flow exporter, you need to mention the flow monitor and call the exporter under the flow monitor and apply that to an interface. So here the interface is VLAN 1.
some of the useful commands that you can verify whether I'm exporting the statistics is that on the soup2t, this is specifically for soup2t, is that the show platform software flow internal export statistics will give you an exact idea on how many packets are getting exported at one point of time. You can also go ahead and clear the flow monitor statistics in order to identify how many packets are getting exported at one point of time. So we're going to move to 6800i instant access switches. The A was missing there. So there was an next generation switch. So the plan is we have Nexus 2000 in the Nexus 7000 platforms. We have Nexus 2000 where we can connect and explore a lot of things. Similar to that, we have brought 6800 instant access, and we are going to connect this as a FEX to the instant access parent. Instant access parent is nothing but the normal 6500 soup2t, and the 6904 is the first line card to support these features. 6904 is the first line card to encapsulate and decapsulate the VN tag that we are going to discuss right now. So the main purpose behind introducing 6800 instant access switches is that to extend the ports and to have a flexibility from comparing to the Nexus 7000 Nexus 2K platform, introducing the same kind of setup in 6500 as well. So what is 6848? 6848 has two options, one with PoE plus, another one is gig ports. PoE plus is an additional feature that you get only in 6848, and you don't get the PoE option in Nexus 2K. So you get that only in 6848 instant access. You have two 10 gig uplinks that can be bundled up. I can talk about that more on the stacking part. So at this point, we can stack only 3 clients, but we have plans to support up to 5 clients and extending the ports to port density to around 2000 ports. As of now, we don't support 2000 ports. We support 1008 ports in total. So the 80 gig bidirectional stack bandwidth would be available, and full PoE support for 15 watts would be for 48 ports. PoE plus would be for 24 ports. That will be for 30 watts. So there's a single fixed power supply. There's no redundancy as such, and there's fixed fans for the 6848 instant access. So the key part here is everything is being automated. So there's no licensing required. There's no separate license required for 6848 instant access. The 6500 code bundles the FEX code, and you will get the FEX code available in the latest release itself. So you don't need license. All you need to do is just upload the iOS, and FEX automatically downloads the FEX code from the 68 or 6500 instant access parent. So here's what happens behind the scene. So whenever you have an instant access 6848, when you connect to an instant access parent, at the background, there are several protocols that work hand to hand, and that will help the 6848 to come up and forward traffic. So the first protocol is the satellite discovery protocol. So what happens exactly is you don't need to configure anything on the 6848 IA. All you need to do is the configuration on the ports on the 6904 line card or the 6807 chassis. So what you need to do is you need to go ahead and mention switch port mode FEX fabric. That will enable the VN tag encapsulation and decapsulation on a FEX fabric. And I'm going to talk about what VN tag is. And you associate those ports, those IA parent ports, to a certain ID. The ID that you're going to mention here will be used as a communication between an IA parent and an IA client. So when you put a switch port mode FEX fabric and FEX associate under a port channel, it automatically bundles and brings up the link that's on the client side. So SDB does this function, and there's a satellite registration protocol that specifically does the registration part. So when it comes to the registration part, it assigns the WIF to each of the LTL ports. So when I say 6848, it contains 48 ports. Each port will contain an LTL, and an LTL will in turn be mapped to a virtual interface. Each virtual interface will be assigned, and this FEX will be a part of the 6848, or 6848 will be a part of the 6500 itself. So, and the other protocol is the configuration protocol, which maintains the configuration status and the statistics. And also you have intercard communication protocol that maintains the syslog. SCP and ICC plays a key role. Because of these protocols, we can operate the 6848 IA client from the 6500 chassis itself or a 6807 chassis itself. The switch discovery protocol first sends the hellos, so between the parent switch and the client switch. So this runs between the controller and FEX, controllers being the IA parent switch and the client switch. So a client will be assigned with the client ID, a virtual interface, and SRP will add the 6848 into the parent switch, making it as an interface in the parent switch itself. And the configuration protocol is what helps you in managing the configuration. When you do it from the 6500, SCP carries those information and apply it on the 6848 IA ports. So there's also an intercard communication. The intercard communication does the heavyweight, the syslog and the QoS statistics are all maintained with the help of ICC. So let's look at what a VN tag is. A 6500 is a chassis, and 6500 IA, it's not a 6500 IA, it's 6800 IA. 6800 IA is the instant access client. Okay, 6500 is completely different than 6800 IA. But 6500 chassis and 6800 IA works hand to hand, so that both behaves as one single switch when we do the configuration. So let's look at the VN tag. VN tag is the key part in the communication between the 6848 IA and the 6500 chassis. So what happens exactly is when you have a FEX, when you bring up the FEX, each packet that is being passing from the FEX to the 6500 chassis will be VN tag encapsulated. So the 6848 instant access will add a 6 bytes to the packet, and that specific packet is going to go all the way to the IA parent switch, and IA parent switch is going to decapsulate the packet, VN tag packet, and going to do the normal forwarding. So what does VN tag contains is, VN tag contains the source virtual interface, destination virtual interface, and the D bit and the P bit, and the VN tag ether type. VN tag ether type is the 8926. So whenever you see a packet of ether type 8926, that's a FEX packet. That's a packet which is coming from a 6848 instant access. So whenever the D bit is set, which means that that's a unicast packet. Whenever a P bit is set, which means that it is a multicast packet, and it will be pointing to a group WIF. So you have the destination WIF and the loopback bit as usual, and we have source WIF pointing to the source interface, destination WIF pointing to the source destination interface. So we are going to look at the packet walk on what happens exactly at the first point. So when at first point, when we bring up the IA parent, the IA client is connected to the IA parent. So at first, we are going to have an interface 1 and interface 2, and we are going to have interface 1 associated with the virtual interface 1 and interface 2 associated with virtual interface 2. Now what happens is, during the SDP process, WIF1 is associated, will be assigned to IF1 interface, that's interface 1, and WIF2 will be assigned to IF2 interfaces. So all these things are automatically assigned, so you'll not be knowing it. All you need to do is associate the fabric and unshed the port channel. So one WIF will be associated to the host port and to the ether channels, and whenever the WIF is equal to 0, that means that the packet is for the IA parent itself. And for multicast and broadcast, as I said earlier, we have a group WIF that will be found in the table. So let's look at the packet walk between host 1 and host 2. So we have a source MAC plus the destination MAC plus the payload. It's going to go to 6848. 6848 is going to encapsulate the packet with the VN tag. with the source WIF information. It's going to go to the 6500 chassis, and from the 6500 chassis, there's a module like 6904. 6904 have the capability to unstrap the VN tag, and it'll look at the source MAC and DMAC. Now 6904 will say that, okay, my source MAC is learnt via this port, and my destination MAC is learnt via this port. So he's going to do a normal lookup, and he's going to revert the packet back to the 6848 instant access client. That's because the host 2 destination MAC address is learnt on the instant access, it's learnt via the instant access client. So it's going to do a lookup and says that, okay, it needs to go back to the 6848. It's going to encapsulate the packet again with the VN tag, but this time the DWIF will be set to WIF2 because the packet is going to the WIF2. And then once it reaches the 6848, it's going to see the VN tag, and it's going to just forward the packet to the host 2. So let's look at the multicast or a broadcast packet. So imagine if there is a group and there's a receiver, and both the receivers are subscribing to the traffic, and both the traffic and both the receivers have to receive the multicast feed from the source. So what is it going to do is it's going to mark IF1 and IF2 in the group WIF, and that specific source will forward just one multicast feed from the 6500 to the instant access. So while forwarding it, the 6904 will make a decision stating that these are the WIF interfaces from which the receivers are subscribing the traffic to the source, and it's going to add the VN tag and DWIF as the group WIF. So in the group WIF table in the 6500, we are going to have multiple WIF interfaces. So whichever receiver interfaces have subscribed to the feed, it's going to get the traffic. So here we have VN tag and the P bit set to 1, which means that it's a multicast, and it's going to forward it to a DWIF, that's to the group WIF. And both the receivers will be receiving the traffic, but the replication will be done on 6848 instant access client. It's not done on 6904. This is mainly to consume the traffic on the uplink between the 6848 IA and the 6500 chassis. So there is also an option for instant access provisioning. So all you need to do is configure and connect the fetch. The stack member will be automatically discovered from the master, and it will be automatically configured. So all the interfaces will be up once you do the instant access provisioning. So what happens in the background is when you have a stack, 6848 IA chooses the master and the member. So the master will in turn communicate with the IA parent, and it will try to see if he's running the same fetch code from the DIR microcode directory. So if he's not running the same code, he's going to download the code from the IA parent. Note, the fetch code that's going to get downloaded only for the master in the stack. The member port will not communicate to the IA parent. So once the IA parent downloads the fetch code, it's the master's duty to upgrade the code to all the stack members. So we're going to talk about on how an auto provisioning is being done. So, and also adding uplinks is pretty much easy. So if you want to add an uplink, all you need to do is add the ports into the port groups, and automatically this will be added into the uplink ports. The more you increase the uplink, the more you get the bandwidth on the uplink ports. So the key thing that you need to look at here is when you have a 48 IA ports, you have 4.8:1 OR subscription. When you have a stack of 3 IA 6848 IA instant access, you will have a 14.4:1 OR subscription. That's because of 144 ports. So as of now, each stack will support only maximum of 3 6848 IA client, and you cannot use more than 3, but more than 3 is supported from the release that's going to get released in December. That's the time frame. So there's an instant access provisioning option. There's also a pre-provisioning option. Suppose if you need to configure or provision the fetch as of now, and during the night time, the field engineer is going to connect the stack member. All you need to do is pre-provision the FEX, and all the things that field engineer is to do is just to connect the uplink to the 6500 chassis. So everything will be automatically done once you execute this pre-provision configs. There's also a virtual slot mapping. So what happens is, if you type the FEX as 121, there's automatically a virtual slot map is assigned to it. That's in the VSS setup. So the virtual slot map will be used in forwarding the packets back and forth from the IA parent to the IA client. So if you look at the once you configure the FEX, you can see the running configuration of the ports. So the ports will become normally usable for a host port. You can add switch port mode access. It will be like the first thing will be the FEX ID, second thing will be the switch number, and third will be the 0, it will be common, and fourth will be the port number. The reason for the numbering is it's little different compared to the Nexus. So you have 3 denominations in Nexus, but you have 4 here. The first thing is the FEX ID, second thing is since we have stacking available here, we follow the port numbering system as this. So all you need to do is it's a client host port, it's a regular port. You can put that in the access VLAN, and you can do a normal spanning tree on these ports. So as I said earlier, automatic discovery is supported, and also pre-provisioning is supported. So all you need to do is mention the number or the part ID, that's WS-C 6800 instant access. And most of the times we do miss the slot. It has to be mentioned. Slot has to be mentioned for the stack. If it's in standalone, slot need not to be mentioned. Just mention the type, that will be enough. So the main thing that I've told as earlier is no console access is needed for the 6848 instant access. All you need to do is configure the switch port mode FEX fabric. Once you enable that in the port channel, all the physical ports associated with the port channel will be VN tag enabled, and it will encapsulate and decapsulate packet. And you associate those port channel into a FEX ID, and you bring up the FEX, and everything should be done. So if you notice, once you bring up the FEX, it will be online with the port channel number, and the image version check will be also an overridden one. You can also see in the extended model, you can also see WS-C 2960. Also, you can see 6880X versions. So these are all the recommended design that we have tested. So we can have a dual home to VSS pair. We can have dual home across the stack members. We can also have up to 6 uplinks MEC, but the 6 is the limitation, maximum of 60 gig. But we are going to support with 5 in 6848 instant access in the coming up releases. So the uplink capacity is going to increase pretty soon. So I see some of the questions coming up in the slides. Fabric path will be only supported in the Nexus 7000, and it will not be supported in a Catalyst 6500 because Nexus 7000 supports the trill-based platform. So 6800 instant access client cannot work as a standalone switch. So it has to work with the 6500. You need to have a 6807 chassis, or you need to have a 6500 chassis SOUP2T with 6904. It will not work without a 6904 or with the VN tag encap decap support. So these are all the instant access unsupported topologies. So if you have a FEX, you cannot connect between 2 different VSS domain 1 and VSS domain 2. You cannot connect the FEX like that. That will not work. That will create a loop. And the VSS mode, you cannot connect again the switch to a stackable member 6848IA and a standalone 6848IA. That's also is not supported. And also, you cannot have the same switch connected to IA parent and IA client at the same time. So these are the references, and this was polling question 3.
Okay, so let me take the polling question 3. So how useful was this presentation? And there are 4 options. Option A, this was very informative presentation. Option B, this presentation needed more in-depth details. And option C, I wanted to see some information on configuration. And the last option D, this presentation was somewhat useful. So please take a moment to post your responses to this poll. Okay, so you can also submit the technical queries. As I can see Varun and Subhaya, they are really busy responding to all your questions. And now we'll jump into the some of the questions that you have submitted today. And by the way, if you can't stay with us for the Q&A, please be sure to click on the evaluation that will pop up once you close the browser to let us know how the session met your business needs and expectations. You can also access the survey. The link will be shorted postly in the chat. So now let's get started with the Q&A. And the first question is, Richard Somu, the question is, are we having 2 uplinks from the FEX to the 6500? Does spanning tree block one of the ports?
So no, the uplink ports will not be blocked, and it'll be always forwarded. So whenever you have an uplink from the 6848 instant access client to the 6500, so that port will not be blocked. And also I would like to answer one more question that has been raised by Bhavesh. So what happens is exactly is 6500 SOUP 2T is not a trill-based platform. So Nexus 7000 is a trill-based platform, and Fabric Path is built only for Nexus 7000 as of now. So we don't have the we don't have the support for Fabric Path on Catalyst platforms, but we do have the support on Nexus 5000 and 7000 only. Hope that clears the confusion there.
Okay, thank you, Richard. The next question is Trust DSCP/COS supported in IA clients?
So as of now, the port supports only Trust DSCP, and we don't have the support for other Trust COS as of now, but Trust DSCP is definitely supported.
Okay, thank you. There is another question that says, how many queues are supported in 6848 IA?
So when you mean the queues, it's about, there are 4 queues in 6848, 1 priority queue and 3 standard queues. So we can go ahead and tweak whatever way we want. So priority queue will carry all the control traffic like BPDUs, etc., and all other standard queues will be used for the normal traffic mapping.
Okay, thank you. Another question is ISSU supported on 6500 with a 6848 IA client?
Yes, ISSU is supported on the 6848 client. We can use ISSU for upgrading the 6848 devices.
Okay, thank you. Let me take a few more questions. So is COPP enabled by default on the SOUP 2T?
Yeah, that's right. So I have explained in one of the slides that control plane policing is enabled by default on SOUP 2T, whereas in SOUP 720 we have to manually enable it. So in case of silent drops, we definitely need to look into the control plane policing by executing the command show platform control plane police.
Okay, great. Another question that says, if the master resets, does the uplink ether channel gets reset or does it fail over?
So the failover is pretty fast, and there's not going to be an outage even if the master stack member uplink ether channel is going to get down. So the failover happens pretty fast if the stack member is also connected to the uplink stack IA instant access parent. So the failover is going to be pretty fast, and there's not going to be any outage expected during such events.
Okay, great. The next question is 40 gig module supported on 2T? If so, what is the model number of the line card?
Okay, on SOUP 2T, we have a 40 gig line card capability, and the model number is WSX6940. And one more thing is, we can use that particular line card to be a gig port as well. And the best place to look about that card details would be the data sheet. So yeah, you can get that in CCO.
Okay, so let you all know that Somu and Richard will be hosting an Ask the Expert. So any follow-up question you have, you can ask in the Ask the Expert discussion. Also, we will be posting all these questions that came in during the webcast as a separate document that will be called FAQ from Live Webcast.
There's one question from Hemant here. BVIF is group with Montecast group list.
Yeah. So as I said earlier, you have in PICS host port. So host port will have different WIF interfaces. So let's say port 1, 2, and 3 are assigned with WIF 1, WIF 2, and WIF 3. And if all these three hosts, which are connected to WIF 1 and WIF 2 and WIF 3, are subscribing to a group for multicast, then the destination DWIF will be set to group WIF. The group WIF will contain the information of all three WIF 1, WIF 2, and WIF 3. Hope that clears.
Okay, thank you. I'll take a few more questions. The question is, how many 3-switch stacks can be connected to the 6500 chassis?
So at present we have 7 node support. So total of 216848 chassis. That adds up to 1008 ports. So we can add up to 7 nodes. Each node carries 36848 instant access stack members.
Okay, great. Okay, so the next question is, who takes the decision for the packet forwarding when the packet has to exit out of the IA switch?
So let's say if the forwarding is on 6848, let's say we have 6848 IA. So there's a port, the traffic gets ingresses on 6848 IA, and it needs to look up an SWIF and DWIF table on the 6904 line card. So there's a mapping between the SWIF, DWIF, and the MAC table information in the 6904. So the decision is basically made by the IA parent switch, and the MAC information is maintained in the 6848 instant access line.
Okay, great. So let me take one last question. Is platform hardware rate limiters enabled by default?
Yeah, there are some rate limiters enabled by default, but not all the rate limiters. So if you execute show platform rate limit, we can see the list of rate limiters, and some of the rate limiters are enabled by default. If you want to enable it, others we have to manually enable it, similar to what we have in SUP 720.
Okay, great. So that concludes our today's Q&A portion. I think, Richard, you have something to say?
Yeah. So the question about the trill and the fabric path on the 6500 support. So there's going to be a next-gen SUP will be coming out soon with, that's going to be called SUP 40. And that will be with OTV trill support ready. So that's the key information that you can have. But 2T in 6500, we don't have trill support or fabric path support. It is planned in future.
Okay, great. Thanks, Richard. So that concludes our Q&A portion for today's session. And we appreciate your feedback. And those who fill out the evaluation survey will stand a chance to win a raffle. The prize is a Cisco Press ebook, which is worth $80. The survey link will be posted in the chat. Also, when you close the browser, you will get the link to the survey. Okay, so as I mentioned earlier, Richard and Somu will be hosting an Ask the Expert for next 2 weeks. That is from March 11 today to March 21st. The link is there on the slides. Also, it will be posted in the chat. So for any follow-up question on this topic, feel free to ask them. They will be available for next 2 weeks till March 21st. And we'll be posting this recording and the Q&A portion within 5 business days. Okay, so some of you might have seen on the promotion we have asked a trivia question. And the question was, how do Cisco Catalyst 6500 and vacations have in common? So that's an interesting mix. The option A is, in the year 2001, the first 10 gigabit Ethernet modules for the Cisco Catalyst 6500 series switches were developed and the travel company Orbitz was founded. Option B, the Cisco Catalyst 6500 was used to revamp the data center for Orbitz travel. And option C, like if you think both of them, so option A and option B. So please take a moment. I'll be providing the answer a bit later. Okay, so these are some of the upcoming events. So the next webcast, which is happening in Russian language, the topic will be deploying and troubleshooting Cisco Unified Contact Center Express scripts. It will be happening on March 18th. That's 12 p.m. Moscow time or 9 a.m. Brussels time. And our expert, Sergey, he'll be presenting. He will be discussing how to deploy and troubleshoot scripts on the Cisco Unified Contact Center Express. You can register if you speak Russian. Another webcast in March from in Portuguese language. The topic is Unified Communication on UCS, Virtualized Networks by Pedro. It will happen at 11 a.m. Brasilia time or 7 a.m. San Francisco time. And Pedro will present the concepts and trends in UC virtualization, applications, operations of virtualized network with a focus on UCSB series Nexus 1000V and VMware ESXi. Okay, so as you know, we have several languages community in those languages. So another webcast which is happening in Spanish. The topic will be interoperability of Cisco collaboration solutions. It will happen on March 25th, 9 a.m. Mexico City time. And expert Omer will discuss the challenges of overlap in services collaboration and with Cisco and Microsoft, including voice, video, incident messaging, and presence, unified messaging, and web collaboration. Moving on, so this English webcast is happening in April. The topic is securing enterprise LAN on April 1st, 9 a.m. San Francisco time or 12 p.m. New York time. Our expert Vaibhav Katkade, he will be covering various details about the securing enterprise LAN. The registration link of the live webcast is there on the slide. And here are some of the Ask the Expert events which are running currently. The first one is on FSPF concepts and troubleshooting in Cisco SAN environments by Upinder, which will end on March 14, that is this week, Friday. The second Ask the Expert, which is currently live, demystifying long-term evolution with experts Rahul, Arpit, and Krishna. And this will also end this Friday, that is March 14th. So if you have any questions related to these topics, you can log into the Cisco Support Community, Expert Knowledge Community, and there you can see these events live. And these are some of the upcoming Ask the Expert. The first one is on topic installing, integrating, and troubleshooting unified connection with Brad. It will start on March 17th. The second Ask the Expert gonna start is SAML SSO for UC10X with expert. The expert details are not there, but you can ask question on if you have on SAML, SSO, and UC10X. And here is a Google Meetup. The topic for the meetup will be working on compliance management and configuration, CMCS. It will take place on Thursday, March 13th, which is at 12 p.m. to 2 p.m. Santa Clara, California. Our experts joining for the meetup will be Mark Doring, Technical Marketing Engineer, Cisco. Okay, so we have a new look. I don't know if you have gone to the Cisco Support Community. You might see a different new look, exciting new look. So I would encourage and welcome everyone to log into the new Cisco Support Community, which is now live. And you can also, if you haven't explored the Cisco Support Community till now, I welcome you to come, log in, and ask questions. Okay, so this is our class of 14 for top events contributor. So again, in the community, if you go to the leaderboard, you will see people who have contributed, presented in all the live events and Ask the Expert events. So they have been chosen as the top events contributor. Some of them are from Cisco, some of them are outside of Cisco. Okay, and we continue to have all the presence in social media network. So if you are active on any of these social media channels, feel free to explore. There's a lot of documents, content, and information available wherever you are. So feel free to explore all the social media channels, and you can also subscribe to the newsletter so that you get updated information on all the events happening, some of the top hitting content like documents, videos, and blogs. And as you know, we continue to expand our reach in local languages, and we have communities in other languages like I've seen before, some of the live events happening: Spanish, Portuguese, Japanese, and Russian. We also have a Chinese community which is live now, and to access, the link is provided in the presentation, or if you log into the Cisco support community, on the top right corner you'll see some of the languages. From there you can go to the Chinese website. Okay, so rating helps to segregate or to know which content is really good. So feel free to rate as you see fit. Whenever you go to a discussion, a response from an expert, or if there is a content like documents, video, and blog, feel free to rate those content. Okay, so time for answering the trivia question. Okay, great. So I think 64% of attendees have got the right answer. Yes, the answer is C. In 2001, Orbitz Travel Company was founded, and the first 10 gigabit Ethernet 10 GBE module for the Cisco Catalyst 6500 series switch was developed. The Cisco 6500 was also part of the new infrastructure for the Orbitz Travel Data Center. Orbitz noticed more uptime and higher sales. The higher their availability, the better the online sales numbers and their bottom line. Okay, so before signing off, please take a few minutes to complete your evaluation for today's session. This will help us address some of your business needs and interests for the future. And this concludes our session today. Thanks to our expert Richard and Somu for sharing their expertise with us today. And also thanks to our expert panelists Varun and Subbiah for answering many of the technical questions that users have been asking. Thank you all, and have a great day.